Hi YouTubers, welcome back. We are doing grade 12 cyclic geometry. We are solving problems using the theorems that we've been practicing some while ago. Now this is what you are given. You are given this cycle. The statement says in the circle, in the diagram, O is the center of the circle and EC is a tangent to the circle at C. dm is given to be equals to MC. dm is equals to MC. And OME. OME is a straight line. Let O1, this angle O1 is equals to 2x. That is what we are given. Now, question number 1 that will follow, they say write with reasons 3 angles equal to x. Question 2, prove that O2, this angle here, is equals to 90 minus x for 3 marks. This one, once you see 6 marks, it means that you have to work. This one is 3 marks, also you have to work. Then come for number 3. Prove that EC is a tangent to the circle passing through points M, C, and O. Passing M, C, and O. So it means that if they say that this is EC is a tangent, it means that you use that 10 chord theorem that is going to give you that this angle must be equal to that angle. If it was said that prove that EC is a tangent to the circle passing through points, now we are not talking about MOC, we are talking about DOC. You see? So that means that this angle, the angle between the tangent and the chord, is equal to the angle in the alternative segment. You are going to take O2 and O3. You see? But because they want it to be a tangent from MOC, it means that the angle here is going to be O2. O2 must be equal to C3. This is what the statement wanted to prove. Now, number 4, state that DOC is a cyclic quadrilateral for 3 marks. Before we can do anything for cyclic quadrilateral, grade 12 and grade 11 also, you are also included here. 3 conditions which qualifies for the quad. In order for the quadrilateral to be cyclic, 1. Remember, you must prove that opposite angles supplement. See, let's do that example. Here you have the second, here you have a quad. Quad A. This is point A. Let me take a different top. This is point A. This is B, C, and D. That means angle A must be equal to angle C. In order for this to be not equal, angle A plus angle C supplement. When you supplement, you equate to 180 degrees. So this and that is an opposite angle. And B plus D combined together, you must get a 180 degrees. Now then, this qualifies to be a cyclic quadrilaterals. So we go for condition 2. Condition 2 says that exterior angle is equal to opposite interior angle. How do we see it? Let's do this. Let's do the example again. I'm not going to use much space. Now this is our triangle. We have the same A, B, C, and D. But this time, we extend A, B, C, D. Now, in order for this to be a cyclic quad, this is the exterior angle, must be equal to the opposite interior angle. That means this angle is equal to that angle. Angle C, let's say this is 1 and 2. We have proven in the previous videos that C2 is equals to angle A. The exterior angle is equal to the opposite interior angle. This is second condition. The third condition says that angles in the same segment are equal. This is a butterfly theorem. The butterfly theorem says that A, B, C, D. Angle A is equals to angle D. Angle B is equal to angle C. A is equals to D because it is subtended by the arc BC. Or you can say chord BC. Angle B is equals to C because they are all subtended by the arc AD or chord AD. This grade 12 and 11 you must take along with and run with it, because you cannot survive without knowing that a cyclic quadrilateral has got 3 conditions. The first one is this, the second one is that, the third one is this. So go and memorize this. Do not memorize, in fact, you must know this off by heart. You must know this off by heart, because now we are going to use it here in the last question. Right, let's start with question number 1. Question number 1. Question number 1 says, write with reasons 3 angles equal to x. You see, this is O1, O2, O3. Remember the theorem that says angle at the center is equal to 2 times the angle at the circumference. So this is what we are going to use. O1 is equal to 2A. This O1 is equal to twice that angle. The reason is angle at the center is equal to 2 times angle at the circum. This is 2 times that. But O1 we're given that O1 is 2x. 2x is equals to 2a. You divide by a by 2 here, you find that x is equals to a. This question, it is a very concealed question, this one. Usually the question like this, they give you that ln a is equals to x. They did not give you that, they gave you 2x. But they want you to find the angles which are equals to x. Do you understand my matrix? So here it's a matter of you playing around numbers with your knowledge of the theorems so that you can find x. Now that we have find 1x. This is point number 1. In other words, we have 2 marks. Now let's find another angle equal to x. You see this angle. If you can say CB is an arc, what does this arc does? It subtends equal angle at the alternative segment. This is condition 3. Angles in the same segment are equal. We said this angle is equals to this angle and this angle is equals to this angle because they are both subtended by the same arc BC, or they are both subtended by the same arc AD. So we come and apply that one here. You say that angle A is equal to angle D. Reason? Same segment. If you don't want to say same segment, you can say subtended by the same arc or chord. Which chord is that? BC. Now we have the second angle, which is equals to x. A is equals to x, that means A is equals to D is equals to x, the second angle. The last one. This is the second one. The last one. Let me state the reason first, the statement. Angle D is equal to angle C2. Angle D is equal to angle C2. Reason, remember, this is center. This is the radius OG and OC. If this angle, this side is equal to that, it's an isosceles triangle. It's a triangle like this. If this side is equal to that, then the base angle are equal. So this is the base, this is the base. So you say D angle D is equals to angle C2. Reason being, base angles rising from radii OG is equals to O6. Now this is the third angle. You've taken all your 3 marks. Now we go for question 2. Question 2 says, prove that O2 is equals to 90 minus x, which is 3 marks. O2 is equals to 90 minus x. Let's check O2. Here is O2. You see, this O2 is in triangle OMC. We can start by saying, consider triangle. In triangle OMC. This one, let's give this names. This is 1, M1, this is M2. Right. We say OMC here. OMC, we have M2, right? M2 is equal to 90 degrees. Can you give me that reason? See, this is a radius coming from the center to the circumference. Theorem 1. Theorem 1, this is the converse of Theorem 1. Theorem 1 said a line from the center through the chord. You see, it bisects. Once it bisects, it means what? Say 90 degrees. So it's a radius bisect the chord. Once it bisects the chord, it makes a 90 degrees. Right. We have M2 as 90 degrees. So if we have M2 as 90 degrees, what we can say? We can say that M2 plus O2 plus C2, they make a 180 degrees. You see? Now, what we can say here? We can say M2 plus C2 plus O2. They are 180 degrees, which is a sum of the triangle. Right? Right? They want us to find O2. What is C2? C2, when we come here, we say that yes, C2 is equals to X. C2 is equals to X. We calculated it here. Here is D is equals to A is equals to X. D is equals to C2, which means C2 is X. Right. C2 is X. We have 90 degrees plus X plus O2, which is 180 degrees. Now, let's find O2, because they want us to find O2 here. Find O2, that is 90 minus X, right? We say O2 is equal to 180 degrees minus into X 90 plus x. Then O2 is equals to 180 degrees. Negative times positive, it's negative 90 degrees. Negative times positive is negative x. 90 minus 180 minus 90 is 90 minus x. Therefore, O2 is 90 minus x. We have proven number 2. Let's go for number 3. Prove that EC is a tangent to the circle passing through point M, C, and O. Remember what I told you before we start? They are talking about M, C, and O. It means that this tangent here with this chord, they are going to form a angle at that side. Right. Well, this was number 1. This is number 2. This is number 2. Now we start number 3. Number 3 says, prove that EC is a tangent to the circle passing through points M, C, and O. Right? Where can we start with this question? We must find that C3 is equal to O2. How can we find that C3 is equals to O2? Your C3 here is C2 and C3 is equals to 90 degrees. C2 plus C3. C2 plus C3 is equals to 90 degrees. The reason for that is because this is the line, it's a radius from the center to point C. It is perpendicular to the tangent. So this is 90 degrees. The reason for this is what? Is radius perpendicular to tangent. Radius is perpendicular to tangent. Right? We must find what? C3. What is C3? C3 is equals to 90 degrees minus C2. But C2 we have proven in question 1. That C2 is equals to D is equals to A, they all equals to X. Now we can say C3 is equals to 90 degrees minus X. Once we see that C3 is 90 degrees minus X, we have O2 as 90 degrees minus X. You see? O2 is 90 degrees minus X. That means this tangent, together with the chord, they form the angle which is equal to the alternative segment. Therefore, we can say that, therefore, okay, this is where we're working now. Therefore, EC is a tangent EC is a tangent to the circle passing through these points M, C, O. Right, now let me just a little bit to brief you. We have found that C3 is equals to O2 because they both equals to 90 minus x. If this angle here is equal to that angle, that means this chord and this tangent, they form an angle that is going to be, you see, it's going to be equal to the alternative segment. That means this is a chord, this is a tangent that passes, EC is the tangent that of the circle through point MOC. See that? So I'm just making an example. This angle is equal to that if we say A, B, C. So this is B1, B2, B3. B1 is equal to angle C. That means this is a tangent TBM. This TBM is the tangent to the circle through point ACB. You see what I'm saying? Because this angle is in that angle. So that angle is going to be the point BCT. In other words, we can also do right, but all in all, I have taught this. You can check that in the previous theorems, but I was just telling you that if they say the tangent at point MOC, that means that the angle in the alternative segment is on the O2. Now, let's go for the last one. Question 4. Prove that DOC is a cyclic quadrilateral. Go and do that for me, and then we will do it in the next video. Right, Uncle Pythagoras saying thank you very much. Please make sure that you understand all this stuff with the practice. Go and practice, make sure that you go to grab the theorems that you have proven so that you can be able to go through this. Thank you very much, grade 12. Good luck for you, for your exams. Make sure that you apply everything that you know. Uncle Pythagoras, signing out.